Okay, so I can see that Sayan has responded saying that we had studied basic gates and their logics and also combinational logic. Okay, uh, more importantly, we had discussed about min terms and max terms, right? So those were the important things that we looked into. So we saw as to how min terms are represented, and we saw how max terms are represented. So one thing that you can keep in mind, all of you, is that um, any equation, okay, can be represented either in the form of min terms or in the form of max terms. Okay, so let us get back to our discussion and continue with the concepts that we discussed in the previous class. Okay, so today we will go a little more advanced. Okay, and we shall to what is exactly meant by minterms and how we can manipulate them and what changes can be done to these equations in order to get started with the circuit design analysis and simplification process. Okay, so just give me a moment while I pull up the notes. Okay, so I hope the notes is visible.
Yes, sir.
Fine, thank you. So this was the last, that we discussed. Uh, we saw the input variables and how we are going to represent them. So if I have 0, then I'm going to represent it with a bar. If suppose I have a 1, okay, I have a 1 here. So I'll be representing with a high value, which is C. C is high value and C bar is low value of C. Okay, so similarly, if I have to denote it, so it's going to be M naught. Keep in mind it is small m, M0, okay, M1 till M7, 1, 1, 1, 7. Observe here, ABC is all high, ABC, okay. Now, if I have to represent the same using max term, okay, now keep in mind in term we are multiplying, okay, and in max term, okay, we are using the sum, okay. So here it is going to be different, okay. Here you're not going to use the bar, but here you're going to use the bar. Just like, if you put a bar on ABC, whole bar, okay, and if you split it, so that becomes your A bar plus B bar plus C, and this is capital M and 7. So capital represents max term and small m represents min term, okay. So I hope we are clear with these concepts. So if there is a bar in min term, there is no bar in max term. Okay, you can just see. Suppose I put a whole bar to this A, B, C. Okay, so what happens? It becomes A double bar plus B double bar plus C double bar. So double bar I gets nullified. So it becomes A plus B plus C. Okay, fine. So continuing our discussion. Um, Today we are going to see what are the canonical forms and what are the standard forms. Sometimes the questions I can ask, um, using canonical forms, explain this concept, okay, or in specific explain max terms, or I can even say using standard forms. So standard forms and canonical forms both are representing the same thing. Okay, so binary variables are represented as min terms and max terms. As I told you, any binary number. Okay, I have 000 here, I have 111 here. So any binary number for that matter, I can go with even 2 bits, I can go with 4 bits, 5 bits, any number of bits. Okay, so that can be represented using either your min term or max term. So using these two, I can represent any kind of binary format. So let us take one example. Okay, I've used 3 zeros till 3 ones. Okay, which is m0 to m7, and I have two different functions. Okay, uh, f1 and f2. Okay, just a moment. Okay, so I will have two different functions, which is f1 and f2. So here these are random. Don't worry as to how I got 1 or how I got 0. Okay, just randomly I have represented zeros and ones. So what I want to convey here is that how we are going to form an equation with f1 and how we are going to form an equation with f2. Okay, function 1 and function 2. So as usual, you know your combinations towards the left hand side, which is from 3 zeros till 3 ones. 0, 1, 2, 3, 4, 5, 6 and 7. Right? It is just like your 8, 4, 2, 1 combination. Okay. Next. A Boolean function may be expressed algebraic from a given truth table by forming a min term. Okay. Min term. So what is a min term? Now go back. So this is your min term. 000. I'm using a bar, b bar, c bar. Most of the times, okay, most of the times we tend to use min terms alone, okay, and very rarely, unless specified, okay, we do not use max terms. Mostly you can see that min terms are used. So if you know the representation of min term, if you just put a bar on min term, it becomes your max term. Representation wise, small m, capital M. Okay, so putting a bar becomes a max term. Okay, so here if you see, I have one function f1 is high, which means I'm getting an output when the combination is 0, 0, 1. Next again, I'm getting an output when the combination is 1, 0, 0. And I'm getting an output when the combination is 1, 1, 1. Right? So similarly, I will take those down here 0, 0, 1, 1, 0, 0 and 1, 1, 1. And I will represent it in the form of my inputs x, y, z. So 0, 0 brings here x bar and y bar. Since it is 1, it is z. Okay. And similarly here, since it is 1 here, it is high, so I use x. And then 0, 0 gives me y bar and z bar. Similarly, I have x, y and z. So if I have to represent it in the form of min terms, okay, so f1 is equal to, I add all these three terms, okay, so these three terms are added and I bring them down here. Now if I have to represent it in the form of m, then I can put it as m1, m4, m7. Why is it m7? Because it is 111, right? Why is it m4? Because it is 100. It is the binary format of 4. And why is it 1? Because it is 001, m1. So it is m1, m4, m7. So similarly, I get the equation for f2 as well. Now you can go back to this truth table, okay, and try to write the equation for f2 if you have your notes with you, okay. Just take down 0 1 1 is giving high value for f2, and similarly 1 0 1 is also giving an output. 110 and 111 is giving values or outputs for f2. The other values you can neglect because it is 0. So which means even if I consider, it doesn't matter because it's 0, it's not giving me an output, right? So I will consider only if I get an output. So only wherever you have high value, wherever f2 turns out to be 1, you pick out only those values and try to form an equation. Are you all able to follow what I'm trying to say? Yes? Maybe one of you can unmute and respond. Are you all following whatever is told so far? Thank you. Thank
Yes,
you.
sir.
Thank you, Parker. Fine. Uh, some of uh, some of you want me to repeat it. Yes, I will do it. Fine. Now let us take F1 as example. Okay. So as usual, X, Y, Z. Okay, these are your 3-bit combinations. So which means I have 3 zeros, 0 0 1, which means I'm starting from 0 1 2 3 4 5 6 7. So these are all my combinations for 3 bits. There is nothing beyond triple one, right? Okay, so next only concentrate on f1. So in this f1 I have high value in this combination. Now how did we get an high value? Randomly I have placed 1. Okay, don't worry about that, just random values. Similarly, I'm getting high value at 100, and lastly I'm getting high value at 111. Okay, so wherever I have 1 in your f1, okay, so corresponding input combinations are picked up, which means f1 is higher, so I will take x bar, y bar, z. So this is one of my term. Okay, so what I will do, I have taken it here, x bar, y bar, z, and then I have x, y bar, z bar because I have 0 0 here, right? So whenever there is a 0, it becomes a bar. Now why is it y? Because first bit represents x, second bit represents y, and the third bit represents z. Okay, so if it is a 1, it is just a normal alphabet, and if it's a 0, I go with bar. Okay, so similarly I get this equation, so I am going to add up all these three, x bar, y bar, z, and then x, y bar, z bar, x, y, z. Now the next step, once I have this equation, I can also represent in the form of minterms. It's a small lettered m, and I can put it as m1 because it is 001. So 001 represents m1. Similarly, 100 represents m4. So you have here 100. So this is representing 4, and all high, all ones representing 7. Okay. Similarly for f2, I should have 1, 2, 3, 4, 4 terms, right? For f2, 1, 2, 3, 4 number of terms are correct. Now we should just verify if that is true. Okay. So it is 1 here, so which means x bar y z, x bar y z, that's correct. Then I have 1 here, so it is x y bar z, so that's also correct. Next I have 1 here, which is x y z bar. Next I have 1 at the last, which is same as this last term, which is nothing but your x, y, and z. Okay. So similarly, I have got equations f1 and f2. So I hope we are clear with this concept, right? How we get or how we form equations. Any doubts still here? Any doubts? You could use the chat box as well. Any doubts you can ask. Fine. Okay, Barbara. Thank you. So what we are doing here, we are having functions f1 and f2, and we are actually using sum. Okay, we are using sum of these products. So this is nothing but your SOP form. Remember in the previous class, okay, I always suggest those students who have not attended my classes previously to actually go through the video. I'll be posting it at the end of the day probably. Okay, and I want you to go through the lectures of the previous class so that we stay connected. Okay, sometimes what will happen, I do understand that you wouldn't have followed certain point. So when I share my video, it's always easy for you guys to get back to that particular point and listen to the explanation again. And I hope all of you have joined my Google Classroom in spite of the explanation, in spite of the video. If in case you have any doubt, you can post it on the Google Classroom, and we can always have a discussion on that. Okay, fine. So in the previous class we had seen about these sum of products, right? So this is nothing but the sum, which is also called ORing. Okay, which is also called ORing. Why is it that we are calling ORing? Because we are adding two terms. Okay, we are adding two terms, two or more terms. Okay, now that we have equations f1 and f2, what we will do is we will try to convert them. Now we have it in the form of min terms, right? M1, M4, M7, these are all min terms. So how can I convert them to max term? If I put a bar, right, just like how we saw here, I put a bar. Okay, and accordingly it becomes my a plus b plus c. Okay, fine. So I will use the same f1 equation which is here. Okay, the same equation I will be writing it down here, and I will be complementing it. Okay, so I'll be adding the whole bar. So once you add the whole bar, okay, what is going to happen? I think all of you know this De Morgan's theorem, right? If it is multiplication, it turns out to be addition. If it is addition, it turns out to be multiplication. So it gets reversed. So f1, okay, f1 is equal to this whole bar. Okay, whatever that we are seeing here, the whole bar. So what happens here? Your addition, okay, the addition that you see becomes multiplication. All the addition turns out to be multiplication. And your x bar, okay, single x bar becomes double x bar, right? Double x bar. So first, in the first case, what we will do is we will break up these bars. So we will break it up and make it into multiplication. Okay, so this plus becomes multiplication, this plus also becomes multiplication, right? So all these terms are written down, rewritten, and arranged accordingly. The next thing is, now I have a bar here, right? Only for the first term. I will again break this bar. So how do I break this bar? It becomes x double bar. Now again x and y is multiplied. So what do I do? Multiplication I can turn to addition. So it becomes x double bar plus y double bar plus z double bar. So in turn, it actually turns out to be x plus y plus z. Okay, so the same concept is applied here also. X double bar plus, now y doesn't have a bar, so it's taking a bar from the upper one. Okay, y bar plus z double bar. So z double bar, I can just omit it, it cancels out. Okay. So similarly, you can find for this third term, fourth, and the fifth term. Okay. So if I have to represent this M2, okay, M3, see wherever there is a bar, okay, those things are taken. Here there is no bar in the first term, so I take it as M0. Okay, but if I have to represent the same thing in my min terms, then it should be x, y, z. Okay, and it is going to be 1 1 1, right? So it is just the opposite. Your min terms and max terms are just the opposite. Here it is, in min terms it is lowercase, and here it is uppercase, and there it's multiplication, and here it's addition. Okay, just the opposite. Similarly, the same thing can be done for your f2 function also. So take your f2 and put a whole bar. Okay, so once you put a whole bar, the same process that we saw here using De Morgan's theorem, we split them up, and this is the final equation that we get, f2. Okay, so what do we understand by these two examples that we saw, these two functions that we just implemented? What do we understand? We understand that, okay, property of Boolean algebra. So we have learned a property of Boolean algebra. Any Boolean function, okay, this is very important. I want you all to note down this. Any Boolean function can be expressed as a product of max terms. Okay, so this is a product of max terms m0, m1, m2, m4 as a product of max terms. Okay, so it is also called as POS, product of sum. So you have products here of what is happening inside. It's all getting odd, which means it is getting summed, it is getting added. Okay, so Boolean functions expressed as sum of minterms or product of max terms are said to be in canonical form. So if I can represent them in the form of these capital M's and in the form of these small m's, okay, then I can say that they are in what form? They are in standard form or canonical form. Okay, so I want you all to take down this last line, okay, the last paragraph, which says Boolean functions expressed as a sum of minterms or product of max terms are said to be in canonical form. Students, any doubt, you can please feel free to ask me. Okay, so any doubt you have so far? Okay, thank you, Surya and Sayan. So I hope these concepts are very clear, right? So before we proceeding into few other concepts, it's very important for you to understand as to how we actually derive data from truth table. So till now, a truth table was just a normal truth table for us, isn't it? But now we are trying to go beyond that. We are trying to extract more data from the truth table, and we are trying to build equations, and we are trying to represent it in a standard format. So standard format is nothing but your min terms and max terms. Okay, so min terms where it is represented as small m, and max terms are represented as capital M. So just imagine, with this kind of information, how much of things that we can do, how much of rules that we can apply, how much of Boolean laws that we can actually implement, how much of De Morgan's theorem that we actually try implementing. Okay, so equations are taken, and then we complement them. Min terms are getting converted to max terms. Now see the beauty of these equations. These are all with addition. Okay, m1 plus m4 plus m7. Okay, but here you see it is all multiplication. Okay, so m naught into m2 into m3. So attention to detail is very much important here. Okay, capital letter multiplication, and here it should be sum inside the bracket. Okay, so a lot of attention to detail is required whenever you perform these calculations. Okay, so I have one example here that we can actually go through. One example for SOP format, okay, which is your sum of min terms, and then one example for product of mixed terms, which is your POS format. Okay, so this is my agenda for today's class. Okay, so we will see one example as to how we are going to represent them. So we have an example here, okay, which says express the Boolean function f is equal to a plus b bar c in a sum of min terms. So this is how you are going to get your question. Okay, so question is going to be, you are given an equation and I am telling you to put it in a standard format or sum of min terms format, and you will have to start working on it. Okay, fine. So before we get started, I want you all to go through this explanation so that it will be easy for us to understand. It was previously stated that for n binary variables, one can obtain 2 raised to n. Okay, so which means suppose you have 2-bit combination, so 2 raised to 2. Okay, so which is 2 into 2. So I will have 4 combinations. What are those 4 combinations? Can someone tell me? Bhargav, can you tell me what are those 4 combinations of 2 bits? You can unmute and respond.
0, 0, 0, 1.
Okay,
1, 1, 0,
okay,
1, 1.
correct. So these are the 4 combinations that, thank you Bhargav, that we will have for 2 bits, right? So similarly, as I increase the number of bits, okay, if I go from 2 bits to 3 bits, then my combination increases, right? Instead of 4, then 2 into 2 into 2, 2 twos are 4, 4 twos are 8. So we'll have 8 combinations. So which means from 0 to 7, 000 to 111 is going to be my combination, right? So all this you can actually keep in mind. Okay, fine. So 2 raised to n, okay, distinct min terms, that any Boolean function can be expressed as a sum of min terms. Min terms whose sum defines the Boolean function are those the ones of functions in a truth table. So we saw wherever there is ones, we picked up, right? So min terms, keep in mind, we are picking up functions having only one. So let's get back to the truth table. Yes. So here I picked up these functions only when there is one. This is for min terms. Now for max terms, if I put a complement, what is going to happen? All the zeros are going to turn 1 and all these ones are going to turn 0, right? So it is the total reverse process of what we consider for your min terms. Okay. It is sometimes convenient to express the Boolean function in its sum of min terms, like I always suggested, previously, that most of the things that we do, the computations that we do, actually we make use of min terms. Okay, min terms is widely used, and if it is not in sum of min terms, um, it can be made so by first expanding the expressions into sum of and terms. Okay, so we can always use the complement option. Okay, so if we draw a full complement on the equation, then it turns out from max terms to min terms or min terms to max terms. So using a complement, using your De Morgan's theorem, using Boolean rules, okay, Boolean laws, we can actually reduce a complex equation. Okay. So each term is then inspected to see if it contains all the variables. If it misses one or more variables, it is ANDed with an expression such as x plus x bar. Now keep in mind, okay, x plus x bar, we can always do this if in case we do not have any expression. Okay, so it is just like, um, using its true and complemented version. Now, if you can, remember, we had gone through few Boolean laws, okay, and there we had seen as to how, x plus x bar or something odd with its own value, what is going to be the, outcome, right? So you should actually remember or try to recall these rules of Boolean algebra. So anything that is added with its complement, true and complemented, gives me 1. So anything with 1 is the same value, right? It is not changing the value. So it is always easy for me to add its true and complemented version if in case I do not have that variable. So we will see that in problem exclusively, and you will understand as to how this true and complemented version we are going to implement. So which means how we are going to use this Boolean law. Okay, fine. So we have an equation now, which is actually telling us f is equal to a plus b bar c, and they are telling us to put it in the form of sum of min terms. Now min terms means what? Small m, okay, small m, and then what happens, it is in what format? SOP format. So SOP format means it is going to be a sum of product. So all this you should remember. Okay. So A plus B bar C. Now it has three variables. Now keep in mind. Okay. Now in the first term, I just have only A. I don't have B, I don't have C. If I want that, so what I will do, as I have explained here, x plus x bar, I take it. Okay, I want B here. Okay, because A into 1 is the same thing, which is nothing but A. It is not changing the value. So what I do, I take B plus B bar. Similarly, I take C plus C bar, because both are 1. It doesn't change the value. And similarly here in the second half of your equation, I do not have A, I just have B and C. So what I will do, I will use A plus A bar. Okay. Now a normal multiplication, rearranging, and use of Boolean loss. That is what we are going to do here. Okay. So I multiply, okay, A, B, C. I multiply with the first term, and the second term is going to be, okay, A, B, C bar. The third term is going to be A, B bar, C. Print it down here. And then A, B bar, C bar. I bring it here. Similarly here, A, B bar, C, A bar, B bar, C. Okay. So all these terms are multiplied, and I have it here straight. Now since I have everything in ABC format, okay, in its true and complementary version, next thing is I can actually group them. If I have two things, I can just consider only one. Okay, so similarly, you see 1, 2, 3, 4, 5, 6. We have 6 terms here, and then we get converted to 5 terms. 1, 2, 3, 4, 5. Why is it so? Because these two are same, so there's no point in having the same terms, right? So ABC plus ABC bar, this AB bar C, this remains. This also remains. I will eliminate this because I already have a replica here, and then I will have A bar, B bar, C. So this is taken here. So 6 terms gets converted to 5 terms. Now very simple, since we have everything in ABC format, okay, so it is just like 1, 1, 1. So M7 plus 1, 1, 0. 4 plus 2, which is 6, right? Similarly, 1, 0, 1. 4 plus 1, which is 5, right? Similarly, 1, 0, 0, which is 4. Okay. 0 0 1, which gives me m1, right? So this is how we actually get our uh, midterms. So your function, okay, now sometimes what will happen is, we may have to express it in a standard format, okay, in a standard format. So just go through this section and try and understand as to what exactly that we are performing. Okay, so what we are trying to do here, can someone tell me what we have done here between the this equation and this equation? What have we done?
ಎಷ್ಟು ಸರಿ ಕೇಳ್ತೀಯ ಒರ್ಸ್ಬಿಟ್ಟು
What have we done here? M1 plus M4, M5, M6, M7. How are we getting this? We are just rearranging the terms, okay, in the form of your ascending form from the lowest to the highest. Okay, so now keep in mind your midterms can be represented as summation. Okay, summation function ABC. Now I have the function here ABC, okay, is equal to summation. I just take 1, 4, 5, 6 and 7, just only the numbers. Okay, so this, whenever I have a summation, keep in mind that it is going to be my midterm. Whenever it is a midterm, I know it is a small m, and these numbers are taken in the bracket. Okay, fine. Any doubt still here? Please ask me if you have any doubt. Any doubts, students? Okay, so we have a question from Sai. Okay, he says how to determine the midterms m7, m4, etc. from the SOP terms. Okay, how do we determine? Fine. Now since it is ABC, okay, ABC means what? It is high value. So 1, A is 1, B is 1, C is 1. So it is just like the truth table here. Okay.
ಯಾರಿಲ್ಲ ಬಿಡಪ್ಪ
See,
ಹೋಗ್ಬಿಟ್ಟ ಯಾರೋ ಚಿಕ್ಕ ಹುಡ್ಗ
it is
ಗೇಟು
1, 1, 1.
ಅವನಲ್ಲ ಅವನು ಚಿಕ್ಕೋನಲ್ಲ
So if it is 1, 1, 1, then I'm going to have as M7. So M0, 1, 2, 3, 4, 5, 6, 7. So whenever it is 1, 1, 1, it is M7. Okay. Now you try to understand. Now you try to see this equation, and surely you will be able to understand. Yes, Sayan. Now you are able to get it. So I think now you are able to get it, isn't it? So any doubts you have now? Any of you have any doubts? Okay. So once again, you just look into the equation ABC. It is high, so 1, 1, 1. So I get 7. Similarly, ABC. One thing what you can do is, you can probably create a truth table, or instead of creating a truth table, I feel it's a complex process. Instead of that, what you can also do is, you can just write down 1, 1, 1, and then it gives you 7 in probably towards your working space. Okay, make a rough working space towards your right hand side or somewhere, and you can just represent it 1, 1, 0, and then you can put it as 6. Similarly, 1, 0, 1. So you can put it as M5, right? So this is how we work out with our equations. The next one is max terms. Okay, so the same logic applies. Instead of summation, okay, you saw summation here, right? So instead of summation, we are using pi. We are using pi. So the same concept applies. Okay, so I think probably we will look into this in the next class. Okay, so as of now, we will stop it here, and I want you all to actually write down this. Okay, watch the video. I will be sending in the link in some time. So watch the video, write down this. Okay, and then you will be able to understand as to how we are getting the conversion tomorrow. Okay, when we start off, or in the next class when we start off with our max terms. Okay, it's going to be easy for you to understand when I'm trying to represent. And in tomorrow's class, what I will also do is we will try to do a conversion between canonical forms. So what are these conversions? Min terms we will convert to max terms we will convert to min terms. So I have a few problems ready for you all, so that we will see how to get things done. Okay, so is that clear, all of you, for today's class? Yes, I hope all of you have understood well, right?
Yes, sir.
Okay, so I'll be just posting in the attendance in the Google Classroom. Okay, and you guys can fill it up. Okay, so just give me about 5 minutes, and I'll be posting in the link. Okay, thank you one and all.